All right, so first of all, I'd really like to thank all of our panelists for appearing today. Let me give a brief introduction to all of them. We're very grateful for them spending their time with us this morning. And so our panelists today include David Leigh. David is the Chief Technology Officer of EOS, where he's responsible for the global metal and polymer system product lines, software and innovation management, and continues to coordinate and support a global research and development team. David brings more than 30 years of experience in the additive manufacturing industry, starting at DTM, which was one of the industry pioneers. He has also been involved in multiple additive manufacturing startups that have been acquired by various companies. Prior to EOS, David served as Senior VP of Emerging Strategies at Stratasys. Kent Firestone is the Senior Vice President of Operations at EOS North America. He's responsible for overseeing the manufacturing, field service, logistics, quality, and materials activities of EOS's North American operations. Kent is a 30-year veteran of the additive manufacturing industry and has served in numerous engineering, operations, and management positions at Stratasys Direct Manufacturing, Solid Concepts, DTM Corporation, and 3D Systems during his career. Vikram Devarajan is the Managing Director of Evonik's 3D Printing Technology Center in Austin. Vikram has been extensively involved in the 3D printing industry, specifically SLS, for the last decade. He co-founded Structured Polymers and led the company as CEO from its inception to an acquisition by Evonik Corporation. Starting with his work at Structured Polymers, Vikram has hands-on experience in identifying polymers and formulating additives for commercially available and in development powder-based additive manufacturing systems. Samantha Snabes is an officer in the Air National Guard and the CEO for Re3D, the manufacturer of the large-scale Gigabot series of extrusion printers. Samantha and Re3D are very focused on social responsibility. In particular, she facilitates connection between others printing at the human scale and/or using recycled materials to access locally driven manufacturing in more than 50 countries. A serial entrepreneur, Samantha volunteers as the global chair of the IEEE Entrepreneurship Steering Committee. Previously, she served as the social entrepreneur in residence for supporting NASA Johnson Space Center's Space Life Sciences Directorate after selling a startup for a DARPA-funded tissue culture device. So welcome, David, Kent, Samantha, and Vikram. We're very, very pleased to have you here today. So for our first question for the panel, from your perspective, what is the biggest challenge facing the additive manufacturing industry today? Samantha, would you like to get us started?
Sure. Well, aside from trying to print from garbage, which has its own complexities, I think one challenge that we might all share is just the need to continue, regardless of the size of your company or where you are in the ecosystem, to push towards standards that can support the scaling and the adoption of additive and advanced manufacturing solutions where they make sense. I know there's been a lot of criticism over the years that sales are limited to solutions or opportunity to support rapid prototyping, and inroads at production scale we don't see that across every industry because of limitations with standards. So whether it's with ASME or SAE or IEEE, America Makes, I think it's incumbent on all of us to participate in good dialogue about materials, types of printing, TDPs, if you're working with DoD to help this technology, because I think it is at a point that it could be used in a lot of industries where it's not right now, truly reach fruition.
Yeah. So Ken, you have a number of years of experience in service bureaus related to additive manufacturing. Do you have some unique sort of vantage points about some of the challenges that you'd like to share?
Yeah, thanks, Carolyn. So yes, I think to me, one of the biggest challenges that we face, and it's been this way for a number of years, is machine-to-machine repeatability from the OEMs. And so it's one of the things that I'm going to try to focus on with EOS. In addition to that, I think another big issue is design for additive manufacturing, and I'm really talking about in the customer space. Many times as a service bureau operator, we would see, parts would come in from a customer and they were not designed for additive. They were, trying to convert from machining prints or something like that. And the success is never as high when you go that route. And so I think more focus on design is really needed to help push the industry forward.
Great. Okay, cool. David or Vikram, anything you'd like to add?
Yeah, so I think the first one is just deconstructing the question, what's the biggest challenge? As engineers, we typically focus on the challenge, right? What's a thermodynamic issue or a heat transfer issue or a polymer issue. But really, I think what we're saying is what's the biggest hurdle for us to overcome so we can scale the technology? So if we look at it in that context, what's the biggest thing? I don't like to just look in a vacuum. I like to look across. And I'll start with a steam engine. We're not going to do the whole history of the world, but when you look at the steam engine, it was developed for a unique solution to pump water out of mines in the Black Country in the UK. And so when they developed that steam engine to do that, they then started to create the study of thermodynamics, the need to do metrology, right? All of those things happened because of the steam engine. And then when they were able to put it on wheels and create trains, all of a sudden what was something to pump water is now assisting in transportation, is assisting in generating power instead of having to use horses. And so I think what we need is the killer app. Right? The biggest challenge for us, because once we get that killer app, we'll figure out how to get machine to machine consistency because there will be a monetary incentive to do so. I think right now we're trying to push a pumping device to the world that really needs transportation. And I think that's what we have to figure out is which is the killer device that will assist us.
Yeah, I think the biggest challenge when you look at it is sort of the intersection of what all the other panelists said, right? You've got the same material made by several manufacturers. You've got the same laser sintering machines made by several different manufacturers. And you've got people who are trying to convert injection molding prints or machining prints into additive manufactured parts. And you don't have standards. You're still using ASTM D638, right? I think the intersection of those and how to overcome that is probably the biggest hurdle and challenge that lays ahead of us. When an OEM is picking out a part today in machining, they don't really say which tool you need to buy or which CNC machining head you need to use. They just say, go machine this part, and then they have a QC process based on that. But today in additive manufacturing, if somebody's picking a part, again, Kent will know this better than anybody else. They go down to even saying what bead blaster head pressure you need, right? So with that level of specifications, I think because the technology is still new in its earlier stages, and as time moves on and it gets more ingrained, some of these things will vanish and it'll be more widespread.
Okay. Yeah, those are really good insights. So, that leads into the next question that I have. What can research centers like ours do to move this forward, right? In most of these really big research challenges, there's a place for industry, right? There's a place for academia. What do you think, what outcomes would you most like to see, or what problems would you most like to see us tackle as a research center? Vikram, would you like to lead us off?
Oh, I think absolutely. I'm actually honored to lead this question because I am a product of that research center. I don't know if it's a good thing or a bad thing, but it is a thing.
It's a good thing.
Yeah, good thing, right? So I think, Dr. C. Prasad, our research center is first of all right in the center of, like you mentioned, right, EOS and ALM and just that, I don't know, the special Austin place. So the first thing the research center is doing is pushing out the next generation of designers and part imaginers that go out and write the specs for the material and design of the parts for the next 50 years moving forward, right? So definitely some emphasis on design for additive manufacturing using the complexities free from the machines that come out, and leveraging that is something the center should do. And I think the other thing that the center should really focus on is trying to take the available list of materials, the available list of machines, and the available list of testing equipment, like I'm talking post parts, right? And trying to combine them in a way to make some sort of a standard that somebody who's sitting in a parts division that's trying to order a part can sort of map back or maybe write the next generation of standards that eventually will be adopted by ASTM. I think that's probably what's useful. That's going to be very useful moving forward.
Good. David or Kent, any comments on how a research center like ours, I mean, there are a number of them around the country, could really help maybe a larger, more established company like EOS?
So I think just to focus on one aspect of it, because the other panelists, I think we all have, not that we have groupthink, but we have very similar perspectives. I think the tip of the spear is something that universities can do. Many companies, an EOS or an HP or anybody who's out there, they don't like to do a lot of failures. But in order to have a successful experiment, you need to have many failed experiments. And I think that's something that universities can really help the industry, is to allow for a lot of failed experiments to get us and move us forward. I think that's something that you guys, having everything that Vikram just described, having that all under one roof, working with key partners to do that, you guys can do the really heavy lifting to get a success and then let industry run with it.
Samantha, from your perspective as a startup, right? What are your thoughts on what research centers like ours can do to help you move the industry forward?
Yeah, I agree with both the panelists, and especially what David mentioned. I think research centers have a huge opportunity to offset some of the risk. As OEMs ourselves, we're committed to product lines, and like for us, we say we offer lifetime customer support. So any change or version can really mess up your opportunity to support your customer well. And so then you have to have basically a separate division, even as a startup from day one in the OEM space, that's committed to research and development and improvement. And it's a lot of burden when you're just getting started. Hardware is hard as it is, and it requires a lot of capital outlay. So I think there's a huge potential to work with, to have more successes like structured polymers, and to support the startup side of the fence by helping wrangle maybe institutional dollars, and to offer students and the opportunity to be placed within small businesses through NSF support or whatnot, in addition to actually pushing the ball forward on the research end. More importantly, I think I really love, one of the last projects you shared is an open source technology. I think despite it being a small industry, there's some competition, but really we're all fighting the same windmills. And so I think what you provide is a way for everyone, the HPs, the EOS, and Stratasys to stand shoulder to shoulder to really break down some of these hurdles. And then finally, I would say, particularly in the US, it's been our observation that there are a lot of students who are really interested in designing, maybe for AM or modeling, but there is not a big focus on training people how to use the machines, how to fix them, how to design for repeatability. And you may or may not even need to be a college student or an engineering student to do that. So I think there's a role for the educational institutions to provide content that could be used, as UT does with ACC, and in trade skills to really stimulate conversation around how these machines are not only designed, but how they're maintained, and to incite conversations with people of all different walks of life to truly allow this technology to scale and all over the world.
Great. So let me transition to my next question. I think one of the unique things that all of you bring to the table is that you've all been involved in startup companies in one form or another at one point, I guess, in your career. I know David and Kent, you were involved very early on in DTM Corporation, which was spun off from UT Austin, and then you've been in a number of companies since then. And Vikram, you were involved in starting Structured Polymers, and Samantha with Re3D. I think, the additive industry is at such a point right now where there are a lot of entrepreneurs thinking about how to start their own companies, and they have interesting ideas for how to move it forward. And so I think all of you have had quite great success in this industry, kind of starting and running companies. And so I wonder if you have some advice for people who are starting up their own companies in this area, or maybe another way to ask that question would be, what factors do you think may have contributed to the success of some of the companies that you've been involved in. David, would you like to start?
Sure. I think networking connections. I think Vikram mentioned it. I think several of us have talked about this kind of coalescence of these people that are able to kind of grow. A grove or an orchard works much better than a single tree because they're able to pollinate each other. And I think you see that in California, with Silicon Valley and all of that, those startups. I think Austin has that. I think one is finding an area and I don't know if anybody listens to podcasts or something, but Joe Rogan is like really big, pushing Austin, all that stuff, trying to get all these comedians and people to move to the Austin area because they build each other up. And so I think good partners in a good fertile soil like Austin is really a key contributor, at least for my success.
Oh, I think David hit it right on the head. I'm sure David will remember I was sitting for coffee with him at JP's Java. That coffee shop isn't there anymore. It was many, many, many years ago, and I was telling him about structured polymers, and his eyes just lit up, telling, let's go do it, right? And the same thing with Kent. I came to him in 2000, who knows when, right? And I told him we need some machine time to print and test this out. And Kent also saw the value of what we were doing. So the networking and connection is that, and on top of that, just keep your burn rate low. The advice piece of it, right? Money is hard to raise. Don't spend it on fancy chairs. That'll all come later. Just keep your burn rate low and use your network to go do whatever you can. Don't pay people.
I love it. I love it, right? The cherry wood office and the fancy chair can come later, right? Okay.
That's right.
Awesome. Samantha?
Yeah, I would add, we've had the honor, especially during COVID, to do a lot of mentoring of aspiring hardware entrepreneurs and people aspiring to start 3D printing companies. And I often have to remind myself that, my mom already loves me and our team loves our product and each other. But your product, if you're an OEM, or your material is shaped by how it's perceived in the community. And so the only way that you're going to grow is by getting outside of your network and getting quick feedback. So we were fortunate to put a real donkey of a printer. Well, that's unfortunate. This is being recorded. But the first version of Gigabot, if you see it on our first Kickstarter campaign at South by Southwest in 2013 when we launched, it was pretty rough. It was shot in Matthew's living room. The electrical box is on the floor, but golly, 20 people in 23 countries bought it, and a lot of Fortune 100s. And that bootstrapped our little factory and catalyzed our growth. So I would say, the only, if we had held on to that printer and if we had mounted the electrical box, maybe a year or two would have gone by and we would have spent a lot of money and we would have just designed it for ourselves. But by releasing it early, we're able to grow with community. So for students listening and people in the space, know that, there are a number of players of different sizes, but there is so much need and so much opportunity. And until you throw it out there and take the risk, you're just kind of stuck in your head in the same echo chamber. So I would say go for it. And if you want any lessons learned, feel free to reach out to our team on Re3D. We love sharing at least what we could have done better or what not to do.
Right. So yeah, that's an important lesson, right? You have to take risks and get feedback on what you're doing, right? So that you can move forward and grow. Kent, you were with Solid Concepts for a number of years and then through Stratasys Direct. And so you really kind of saw sort of a successful company over the years, right? Any factors that you think, contribute to the success of keeping a company going, growing and being healthy over such a long period of time?
Yes. So thanks, Carolyn. In my mind, in any successful business, you've got to have the entire company from the top all the way down to the custodian needs to have a shared vision, mission, and purpose. And, everybody needs to be pulling in the same direction. And I think I saw that, I saw that at DTM. I saw that with Solid Concepts. I saw that in Harvest Technologies when we merged with them. And I think that's a common, a core tenet, I believe, for successful companies. And then I think the second thing when it comes to additive, with it at your customers, you have to really have additive champions. And we saw this at every large customer that we had, I think at both the Harvest and Stratasys Direct, we always had, there was always a champion internally that would help drive, design for additive, converting part numbers that were traditionally manufactured into additive. And so I think those are, those are two of the big components I see to be successful in this space.
Great. So one of the questions that I want to ask is a little bit even more forward looking. Where do you see the additive manufacturing industry in 10 years, right? How will it be different from today? I mean, if we look back, all of us have been involved in this industry for quite some time. And if we look back to 10 years ago, to 2011, and how that was very, very different, I think, from today, right? This industry is moving so quickly. Your crystal ball. I'm asking all of you to look into your crystal ball and tell us, in 10 years, what do you think this industry is going to look like?
Yeah, it's being recorded, so we got to be careful, So, no, I think if you look 10 years ago, like today, I think polymers was leading more in the space than metals. In the last year, we've seen that switch. A lot of that's driven by space, not just aerospace, but space exploration, because they've got particular applications that they can print the whole thing in one. And so it's designed for additive. They actually have an application, again, but back to the killer app. So I think in another 10 years, we will have other killer apps. One on the polymer side is like Align Technologies, which is braces. I think that's a 30 to 50 billion valuation company in the additive space, but they're using additive as a tool. So I think we're going to have more Aligns. Now, what are they going to be? I mean, are they going to be printing shoes or helmets for football players or more rockets for engines? I don't know. But I do think we're going to see more and more of these apps really drive the development of the technology around that.
I agree. I do think that there'll be more printers that are more accessible in more places. I think 10 years ago, there was a lot of discussion about having a printer in every house. I personally don't think that's the direction it's going. Not everyone has a garage like David's, and they may live in a studio department. And as you look at printing functional things, obviously they can be big, and you may not have the space for that. But what I do think we'll see is just as what UT has done a fabulous job in this standing up of this research center and just in the history of the school and supporting advanced manufacturing, is I think we're going to see more centers of excellence. So, and especially too in non-traditional markets where there aren't hotspots of printers already. So thinking about, seeing printers throughout Europe and LATAM and Central America and Africa as well. And I think there's going to be hubs that are known for making car parts, and there's going to be hubs that are more known for supporting aviation, because it really is this ecosystem and community that has to rally together, that will include local stakeholders, as well as those willing to take the risk, in the startup space, in the small business space, materials providers, and OEMs and research institutions that are really focused, and communities that will grow out of that. And then, it's a little bit self-serving, but I do think I would submit that I think there's a good conversation going on right now in the space around sustainability and natural materials. So I think we'll continue to see companies explore what that means for their focus. And I'm really excited to see where that leads.
I think in addition to the applications that David and Samantha mentioned, I want to take a different look at the problem, right? Let's go back at some time when books were the only method of exchanging information. They were printed in one place in one country. Germany had some of the first printing presses, and then they would ship books out all over the world, right? The Gutenberg press. I think that'll change for spare parts in some form or the other. Wherein, today, if you wanted to print something, you would email a file and then it would be printed local. So I think man would not be lugging around, or boats would not be lugging around spare parts all over. Now they may be lugging around, Evonik powders or EOS printer machines where they are at the end install base, but I think the value chain and the amount of miles traveled by the end part will significantly change. If you look at it now, that may not happen in 10 years, it may take 20 or 100, but I think, as Carl Decker said it, right, really the founder, at least from the UT's perspective, as long as mankind is alive, there'll be some machine somewhere making parts using the 3D printing, sintering technology somewhere. So I think we can see a lot of revolution on the way that parts are made and handled and shipped and installed.
So I think David mentioned the killer app, and I believe very strongly that applications will drive the growth in this industry. They always have. I think what we hopefully will see in 10 years is more and more of those where it's a more commonplace thing. I mean, today you can probably name the number of killer apps that really drive a lot of revenue for companies, on a single piece of paper. And so I think, 10 years from now, we'll have a lot more of that. And in my mind, there's one of the metrics we look at least in the parts business, was, what percentage of our parts that we're producing yearly were production applications. And typically that would run in the 35 to 40% range. And it grew a lot from say 2005 to 2015, and we would typically see that grow a couple of percent, maybe 5% a year. I think 10 years from now, for us to be successful, we probably need to have that number closer to 65% production applications and 35%, prototypes, let's call it, because I think that's where the sustainability will come from, and the recurring revenue to help grow and continue to fund that growth. So.
Great. So I wanted to transition. We have a couple of a few good audience questions that I wanted to ask. And one is from the audience is, will advancements in additive manufacturing lower the price of these products so they're more accessible to the general public? And the second part of the question is, if not, then what is the motivation behind doing more research in additive manufacturing? So I think it's a question around pricing and accessibility and things like that.
David, go ahead.
I'll jump on the second part. What's the motivation for research if you're not going to lower the cost? I think it opens the opportunity, right? It's a value, right? Launching something to space is obviously going to cost a lot of money. So it's not just a commodity. So I think that's one of the values, is really opening the doors to things we couldn't have done before. So that's the first kind of popcorn answer.
And to add to that, I want to address the cost issue, right? People usually complain about the cost of the feedstock for additive manufacturing. No one really looks back and sees how many millions of dollars it takes and how many thousands of print tests it takes to put a feedstock out into the market, right? All of that needs to be recouped somehow. So I think the answer to that is, as the adoption curve and the killer apps drive the material and machine consumption up, people can make more. I'm sure at some point a ground titanium bar that meets a particular diameter spec would have been super duper expensive, and over time the cost slowly comes down because it's being, a lot of it's being made. So I think volume of consumption is going to drive the cost exponentially down. And until we see the volume and mass adoption, AM is still going to be a niche. Let's put stuff into David's garage and the Mars sort of applications, right? If it needs to come to the University of Texas garage, I think a lot more of it needs to be used and sold.
Yeah, Samantha mentioned earlier the printer in every home concept that was popular, back in the early 2010s. And I personally, having been in this industry for 30 years, I've never really felt that was a realistic approach. When you talk about cost for additive, it's not, to me, it really boils down to the cost of the parts, not so much the cost of the printers. And granted, one is driven by the other. But if the general public needs a part, done, they can go to a service provider and get that part, typically for fairly inexpensively. But if we're talking about putting printers in every home, then that's a different conversation. So to me, the cost ecosystem is really it really should be driven by the applications, which, you know, in turn is kind of parts, not so much the printers themselves. There are companies out there that will get the printers and put them in and build you parts for a very reasonable price. So.
Yeah, I would echo the comment on demand. From, you know, the OEM perspective, it's no secret because you can sign up for a virtual tour of our factory. We do batch manufacturing in 10,000 square feet in Houston, Texas, and it costs us a lot more at times to source and produce the printers because we handcraft them ourselves with a team in the U.S. So where you see the cost parity, at least on the desktop side, it's, you know, when they're being produced on big lines overseas, say in China, and until there's the demand for, you know, in our segment, large format 3D printers, you know, I have to deal with inventory holding and, you know, paying fair wages in the US and all the other stuff that comes with it. And it's only going to drop so much until you really can justify that raise to have a full automated production line to crank them out. And just as Vikram shared, you know, that cost of the titanium rod then gets a lot lower over time when you're at that level, but it's just not there. We sat in a really interesting conference called Renew 3D, hosted by the University of Maine last week. And one of the analysts that opened up made the comment that in the large format pellet space, for which, you know, there is only a handful of players, there's only 31 units that have been sold or captured for in-house research in the entire United States. So it's no wonder that those machines cost $1 million. So I think, you know, until there's more adoption, and quite frankly, purchases of these printers, it's going to be a little bit pricey for a bit.
So it's interesting, just from my perspective, I teach the additive manufacturing class at UT, and so I teach it every 2 years, and every 2 years the students ask me about the price of making parts and the price of constituent materials, right? Like polymer powders and metal powders. And every time I go back and I look and I do my homework and I try to make sure that I know how much this stuff costs. And it is interesting to me to see that prices for some of the feedstocks, for example, have been coming down. And so if I go back and I look at my notes from, say, 10 years ago, you know, the price of powder feedstock, polymer powder feedstock, for example, has been going down, or has gone down at least over the last 10 years. So some of the things that you're saying are ringing true, right? We're not there yet where it's inexpensive, like, you know, going out to the grocery store and buying something, or going to Target and buying something. But the prices, we are seeing that economy of scale taking effect, at least a little bit, right? But I think your point is really well made, that we need more of it, right? We need a bigger industry, which will then allow a lot of these prices to come down. So there's been some talk in the chat about using additive for parts that are no longer made. And so I think there may be some questions about what % of business do you see this as being a big part of driving additive manufacturing, or a small part of driving additive manufacturing? So sort of, I think, building legacy parts and replacement parts and things like that. So what do you see that being as part of the sector?
It's been probably 10 to 15 years ago. I think it was Dr. Burrell and I from the Austin area participated with DARPA on what investment we could make in additive to really move the needle. And so there's a lot of discussion. Ultimately, it's a multivariable problem, right? Cost obviously is one of them. The speed at which you can produce something is also something else. But the other one is really the engineering behind it. What they really felt that the first step in getting us to where we can actually produce these parts for spare parts was getting the systems 10 to 100 times faster, because they're not going to be cheap systems, but we maybe can make them more productive. And so I think that was the first layer. But really something that nobody's solved yet is really the engineering behind it. I could print you in my garage on a MakerBot printer what they call in the helicopter world the Jesus nut. It's the nut that's on the top of the little shaft that holds all of the blades together. And they call it the Jesus nut because if that fails, all the blades fall off, and you and your helicopter are going to go meet Jesus. So anyway, so I could print one of those, right? I could even take the CAD file and print it, but CAD and printing is not the whole engineering, right? It's materials, it's inspections, it's all of that. I think that's the one thing we really need to work on, is how can we take legacy designs that were designed for something other than additive and translate it into additive speak, right? Can I make that on a 3D printer with titanium when it was designed for, I don't know, cobalt chrome or whatever it was designed with? So anyway, I think that's for me, the main thing is the design engineering packet. And I will say companies are doing that now. We worked with Boeing on one case where they needed to have some spare parts shipped to a place where they had an aircraft that was down and they couldn't get the spare parts to them in time. So they actually had their engineering team design the packet for additive within a day or two and then print them. But there's just not enough digital twin information yet. Anyway, that's my take.
I couldn't agree with you more, and I can speak briefly as an airman myself and supporting a project called Air Force Maker. I have helped push that allows DoD customers internally to share design files. And what blows my mind is when we talk about part obsolescence, DoD is obviously an extreme example, but a number of the components that are on, these ground equipment or airframes or ships, they were made by companies that may or may not exist, and they may predate CAD. There may not be a digital model. So scanning technology has to evolve, digital twins, as David mentioned, and then thinking about the security, whether it's blockchain or anything else, of that digital thread to ensure that quality components are made. Systems for automating TDPs, our technical data packages, are still being designed in order to control how parts are made, and then to vet suppliers and vet OEMs, which traditionally also is biased to really large companies. Not that there's anything wrong with that, but as you see inroads with new companies like structured polymers, you also have to have the capture to be able to work and to qualify and certify these solutions that new companies are offering very quickly. But it's super complex when it comes to that problem set.
Great. So we're running here to about the last 5 minutes or so of our panel. And so I know we have a lot of students who are logged in watching this panel. And so many of them, I think, are asking themselves, this is a really cool industry. I'd really like to be involved. So what advice could you give them for preparing themselves to enter this industry and for entering this industry?
Maybe I'll go first.
I'll take a
I think Ken was about to say something. Ken, go ahead.
Yeah, Ken
Okay.
first.
Sorry. So, I think we need, being in the industry, we need, every day we're looking for graduates that have experience. And, having that experience, coming out of college with the amount of, knowledge that I'm seeing in some of the recent engineers that we've hired out of UT or other schools that have good additive departments, really helps them hit the ground quickly and become a real productive member of our team in a short amount of time. So I think the thing to focus on, it kind of depends on where you want to go once you do get out of school, but certainly additive technologies is probably the first place to start, and then you can take it deeper and start to look at design. We've all commented on how we think design for additive manufacturing is one of the most critical parts of growing this industry. And so design for additive, and then finally additive materials, and if you want to kind of specialize, all those are very high on our list of, when we're trying to look at a candidate and make a decision on hiring, seeing those types of that type of experience on your resume helps us make that decision.
And to add on to what Ken said, I think the one piece of, not advice, but what we did is get your hands dirty, right? Like I'm sure David, and I know Kent and Samantha, when there were times when prints don't work, Kent will come and maybe bump the bed temp a couple of degrees up or down, left or right. It's because each and every one of us have gotten our hands dirty whether it's cleaning parts, again, I come from the SLS world, whether it's changing the roller, trying different things. There is no substitute for doing it yourself. No amount of YouTube videos is going to teach you that. You get powder all over yourself, go take a shower. But I think there's nothing short of doing it yourself, because it gives you the perspective of what to expect. And if even here, when we develop materials, I print with it and I clean it out myself to know that when we sell this powder to a customer, will they be happy doing it? And I think that's also the recipe to build fantastic products that people will pay a lot of money for. So get your hands dirty.
I think one thing is a word I heard from my family is this thing, Kentucky windage. Kentucky windage is when you're going to shoot at something, you need to account for the wind or lead the target. You're not going to aim right at the target, because if you aim at the target, you're going to miss. And so I think number one is do your research on what you'd like to do and where additive may be going. Because right now, if somebody saw the shift back in the early 2010s to 2015, shift towards metals, and then started to do what Vikram and Kent just said, started to kind of get dirty and get practical experience in metals. Right now, there's probably 4 or 5 companies that have just started in the last year or two. They've raised billions of dollars to do metal additive for space, right? And they're trying to scale up fast, and there's not enough people. So if somebody would have started working towards that, they would have a great landing spot right now. So do your research on what you'd like to do and where you can intersect with 3D printing. I guarantee you, if you lead that target, you'll find a place to land, because there's a huge demand for talent right now.
Absolutely. I think we're all hiring. So look us up. But outside of that, I couldn't agree more. You know, in our interview process, we're asking you now to try and put something together or to turn the printer on. Also, it's a way to shamelessly get feedback on usability. And the only way you're going to get that experience is just to start now. So on top of what everyone said, I would just layer a sense of urgency. Go to your garage tonight, or David's garage, or the UT Center of Excellence. Turn on a printer. Feel free to, well, maybe not the gigawatts in there, but feel free to break the hardware, because that's how you're going to learn, and how we're going to grow together as an industry. So we can't wait to see what you print.
All right. I wanted to thank so much our panelists for joining us today. I think they've given us a lot to think about, both those of us who are researchers and practitioners, as well as the students who are coming up through the ranks thinking about joining the additive manufacturing industry as they move forward. So thanks again to these panelists for spending their time and sharing their insights with us today.